The following is a video tutorial for how to create the wheel part for the model miniature train. So first, of course, I'd like to take a look here at the documentation that Project Lead the Way has provided for us. And basically they've given us three different views here. An isometric view from the front side of the wheel, a breakaway view so that we could see some of the detail numbers here on this little peg piece, and of course an ISO view from the back side of this wheel. So we're going to have to actually use all three of these views in conjunction with each other in order to create this part. So first, one of the first things I'd like to do here is I'm just going to jump over to Inventor, and I wanted to just briefly show you the list, the order of operations that I've gone through here to create this part. I started off by creating a sketch, which I grabbed the numbers from this view here, some of the locations and the radiuses that you see here that will help you create that sketch, as well as this number right here, the 0.28 diameter through hole. Because they don't explicitly tell you the distance or the radius or anything inside of here in this view. So you actually have to use this number from down here in conjunction with the rest of the numbers over here to make that sketch. And then of course I revolve that all the way around the y-axis here. The next thing was I created a sketch here, and there's a way that I will show you in a little bit to get all these angles figured out and where these arcs come into play, and I'll just show you real quick here. That's where we're grabbing these numbers here. Basically we have a 15-degree separation and then a 30 and a 30-degree separation in between these lines here, and then this radius, of course, the 0.375, will help establish this first circle, and then the 0.625 will establish this outer rim here, and then from there basically just clean it up a little bit, and then we say finish sketch and extrude that through. And then at that point I can do a circular pattern, and then in which case I did again revolve it around the y-axis to give us our 6 little depletions here. And then the last portion was to create an extrusion at 0.7. So that was an extrusion here of a circle that had a diameter of 0.25, and it was 0.7 from the center of our wheel. Back at the documentation here, I got that number from here, 0.7, from the center of the wheel to the center of where those extrusions are going to be. And then I grabbed that diameter from this breakaway view down here, which was at 0.25. And then next, I created that next diameter of 0.125 and extruded it at a distance of 0.125. So say I finished sketch here. I'm sorry, I actually extruded it upwards then at 0.375, just like we saw in the documentation. Then I created the circle concentric with our existing cylinder here, extruded that upwards at 0.125, and then lastly I added a hole that was concentric as well. I actually placed it using the concentric method and establishing the concentric reference from that cylinder that was existing there. And then of course that diameter was a 0.0625, and it was a 0.25 depth, and we will make this hole with a pointed angled drill point. And that was how I created that hole there. So I'm going to jump back into my documentation here, and I just wanted to show you the last thing. That hole call out was 0.0625 and then a depth of 0.25. It doesn't tell us here whether or not that's going to be a pointed drill point or a flat drill point, but we're going to just make it pointed. So I'm going to come back to Inventor. I'm going to create a new part here. English tab, standard inch IPT, create. I will then create a sketch on this plane here. I'm just going to click on my center roll wheel here and move the pan over a little bit and placing the origin point down off to the side, because I'm going to create my sketch in this area here. Now if we take a look at the documentation again, remember that we're going to have this 0.28 diameter, which is going to be basically the separation. If we cut that number in half, between this dimension line that we see here and where our sketch begins. And then we're going to use the distance here of 1 inch, 0.75 and 0.25 to help establish all of these curves and turns that we see here. So what I'm going to do is I'm going to completely ignore this radius here of 125 and these other radiuses on the inside here of 0.0625. And I'm just going to try to imagine this as if it were to be a square kind of profile, meaning it has right angles and no curves. And so what I see with that is that the distance from our center point here all the way out is going to be 1 inch plus this radius here. So I'm going to lay down my first line from the center point at 1.125. Okay, the next line that I'm going to lay down here will be the thickness, so I'm going to go upwards with this at a distance of 0.25. So perpendicular to my first line here and say 0.25. The next line that I will need to place here is going to be this distance from the edge of our back of the part here going forward. Now if I do a little bit of math in my head, I can see that it's going to be 0.375, because between this dimension line here and this one here we basically have a difference of 0.25, but again keep in mind that we're going to add in this radius because we're starting a little bit further back. So 0.25 plus 0.125 is going to equal 0.375. So that is my next number, my next line. Alright, now I will have to go downwards and at one distance. Come back to my documentation here. I can see that that distance going downwards is going to be 0.125, basically going halfway back down into my part. So I'm going to make that line perpendicular and say 0.125. The next line I will lay down here is going to be the difference between this dimension line here and this one here, and of course we have 0.75 and 0.25, so the difference between that is half of an inch. Making sure my line is straight here, I will go outwards to the left at half of an inch. I will then have to come back up at that same distance as before, 0.125. So going back up here at 0.125. And now this is a portion, the last few clicks here, the last few lines that we got to lay down here, this is the part that's a little ambiguous because it doesn't really tell us the distance here at all, and I'll just zoom in on that a little bit so we can see here a little bit better. You might be inclined to think that this radius here of 0.0625 makes this turn and that's where it stops, and then it just drops right off. But again, we need to remember that this through hole here is supposed to be 0.28 in diameter. So 0.28 is going to be the distance. If we cut that in half and consider a radius for that, will be from the center line here to this edge out here. So if we do a little bit of math to figure that out, it's actually going to be 0.11. And then I will simply just drop my last line here right down. Okay, now I have the most part of my profile set up here. Just going to do some house cleaning things right quick. First I'm going to trim, and I can trim off this inside part of the line here that I do not need any longer. And then next I will fillet all of these edges. It says here on my documentation that these two curves here are going to have a radius of 0.125. So I will fillet those lines first by selecting the top line and then the side line here, and then the side line and the bottom line here. So that set those for me. And then the other fillets that I need to do are going to be this 0.0625, and it's going to be this curve, and then this one and this one. So 4 of them all together. So change my fillet value here to 0.0625. And then just make my way around the top half of the portion here. So pick the side line, the bottom line, the side line to this top line here. So those are all of my fillets. Everything seems to be looking pretty good here. I'm going to now say finish sketch. The next piece to the puzzle here will be to revolve this profile. So I will bring up my revolve command. The profile has been selected for me since it is the only thing on the screen. And then next I have to tell it to revolve around something. I need to give it an axis. Well, I'm going to open up my origin folder here, and I'm going to look at my three options. The x-axis actually runs along the bottom of my sketch, so that's no good. The y-axis here does go up and down, and that would be the direction I want to make it in. Z, that goes back and forth, so that's not going to work. So we do want the y-axis. I'm going to select that next. You can see the profile has been revolved 360 degrees, extents being the full there, that's what we want, and we'll say OK. Just going to hit home here to size up my part a little bit. So the next thing that we're going to want to do is take a look at this view here, and I'm going to set up my angles on the back side of the part to cut out this little depletion area here. So what I'm going to do is I'm going to turn my cube here and flip it to the back side of the part, just so I can create a sketch and grab this back profile here, this back side of the part. So I'm going to select here, and it'll take me into sketch mode. First thing I'm going to do is, well, real quick, I'll just jump back here and remind you that we have a 15-degree separation, a 30-degree, and then another 30-degree separation. So what I'm going to do is I'm going to grab my line tool. I'm going to start in the center of my part here, and I'm just going to draw a line out at no particular distance, but straight out from the part. Alright, I will then place another line here. I can get close to somewhere around 15 degrees, but it doesn't matter because I'm going to dimension it into place in just a second. So I'm going to lay another line down there. That'll be the 15-degree separation. Another line here. This will be that first 30-degree separation, and the last line here will be my second 30-degree separation. Now I will select my dimension tool, and I will click this bottom line here, and then select this line here. Then click one last time to place my dimension, and that needs to be 15 degrees. I will repeat that process again between these two lines and say 30 degrees. And then of course here these last two lines and make that 30 degrees as well. So I have my degrees of separation here. The next thing I need to add in is going to be these two radiuses. So a radius of 0.375 and 0.625, and that's going to help us establish these inside and outside edges. So 0.375 will be my first one. I'm going to go ahead and select my circle tool, and then select the center part again, and it's going to be 0.375 times by 2, of course, because on the documentation it gave it to us in a radius. Here in Inventor we're entering a diameter. That comes out to 0.75. And then next I will make another circle, again selecting the center point of our part, and that will be 0.625 times 2. So 0.625 times 2, which of course is 1.25. Now at this point what I'm going to do is I'm going to trim all of the unnecessary lines that I do not need anymore. Basically what I want to keep is this inside profile right here. So I'm going to select the outside of the circle here, outside of the circle here, and then I will trim up these areas inside of here, just isolating that part as much as possible. And now I could continue to trim, but there's a lot of other lines that are going to keep intersecting here, and it's going to get a bunch of different parts. So I'm just going to hit escape on my keyboard, exit out of the trim command, and then I'm just going to click and drag across the rest of these lines here, selecting multiple at one time, and then right click and say delete. And then I'm going to grab these two little guys inside and delete those as well. That is what I was looking for there. That is my rest of my profile. I'm going to say finish sketch. I will then extrude that profile we just created, and making sure that I cut it out of the part. I could change my distance here to say all, and that way it'll just go through whatever portion of the part that there is, and then I'll say OK. I'm going to flip it around to the front side here. Alright, so good. Now next what I need to do is I'm going to do a circular pattern. First I can select the feature, which will be, computer's freezing a little bit, feature here, extrusion 1, and then the rotation axis will again be that y-axis. That's what we're looking for here, the y-axis. So I will select that. As a default, it gives me 6 and 360 degrees. We do want 6 of them, and it will be 360 degrees, making it perfectly symmetrical around the part here. So I will then say OK. And now we have our cutouts. And then the last portion that we need to put in here is going to be this little peg on the front. And this is actually what that linkage peg inserts itself into. The linkage arm rests around this portion that you see here, and then the linkage peg actually will insert into this hole, locking the arm in place. So we're going to be looking at two of the different views here out of the 3 in order to create this little peg portion here. I'm looking at the distance from the center of point 7 from here to the center of this cylindrical column here. And then of course these numbers down here as well in our breakout view. The first diameter is going to be 0.25, so that's what I'm going to go ahead and do first. I'm going to jump over to Inventor. I'm going to create a sketch and select this flat surface inside of here. Make sure you don't select anything else, any of their surfaces, any of the curves or anything like that, just this flat surface that you see right here. Alright, it should square you up pretty nicely, and what you want to do is take a line and select the center point of our part and bring it straight out to the right at 0.7 inches. Alright, now notice it kind of puts that out into the middle of where this filleted edge is. So when we come and make our circle, which is the next thing I'm going to do, is grab my circle tool. You want to make sure that you grab that end point there. You should see your little green location marker pop up. Again, you can also look for the dimension line, but you should snap to that end point. Make sure you're grabbing that end point. So I will click there and then make my diameter of 0.25. I can then say finish sketch. I will then extrude that circle forwards at a distance of 0.375. That's what we see right here. So we'll change this 1 inch to 0.375. Say OK. Now real quick, I just want to take a note that this line that we put down originally, the 0.7, we did not need to trim it out in this scenario. It didn't get in the way of our extrude or anything like that, so it was just fine leaving it. Next here, I will create a sketch on this surface again. I will then grab my circle tool here, and that will be a diameter of 0.125 that we see right here, and then it will be extruded at again 0.125. So I'll select the center point here, type in 0.125 for the diameter, say finish sketch, extrude our new circle here at 0.125 and say OK. And the very last thing that I need to do then is going to have to be placing this hole, which will be concentric with these 2 cylinders, and it will have a diameter of 0.0625 and a depth of 0.25. So I will come up here and select my hole command. I'm going to place this hole concentrically, so I will use my drop down menu here and select on concentric. First thing I'm going to do is type in my diameter for that hole, which is 0.0625. And of course the depth we said was going to be 0.25. And now I'm going to come over here and select plane, and I will click this top portion of the cylinder here, and then I will then select concentric reference and select the rim of that cylinder. Bumps the hole over into the middle of it, and we want to make sure that we leave our drill point here at a pointed angle. That's what we want, and say OK. And the last thing, of course, is to set our material, ABS plastic. And then I'll take a quick look here at the eye properties menu and say update, and we are looking at a mass of 0.027, an area of 9.812 inches squared, and a volume of 0.704 inches cubed. So then of course I want to cross-reference those numbers with the values that I had previously, and that's exactly what I had. A mass of 0.027, an area of 9.812 inches squared, and a volume of 0.704 inches cubed. So I hope this video was helpful for creating this part. Feel free to like or comment, and thank you for watching.